In our problem, a child is trying to push a 15-kilogram chest across a horizontal floor. He's applying a force to it 30 degrees below the x-axis. The goal of our problem is to find out the magnitude of the force that the child is putting on the chest. The data that we were given in this problem was that the mass of the chest was 15 kilograms. The acceleration that the boy was putting on the chest while he's pushing it was 0.5 meters per second squared. The coefficient for kinetic friction was 0.25. We didn't need to use the coefficient for static friction because the box is moving. And we're trying to find the force that the boy is putting on the chest. We were also given that the degrees below the x-axis that the child was putting on it was 30 degrees.
Alright, first we need to make a coordinate system. The standard y in the up direction, x in the horizontal direction. And then we'd have to break it into components. So we have the sum of the forces in the x direction and the sum of the forces in the y direction. So first, for the x direction, we have the force here times the cosine of 30 degrees, and we subtract that from the force of friction in the opposite direction, the kinetic friction, I should say, and set that equal to mass times acceleration. So we know that the force of the kinetic friction is the mu of kinetic friction, which is 0.25, times the force normal. We don't know what the force normal is yet, so we need to find that. And we set that equal to the mass, 15 kilograms, times the acceleration, which is 0.5. And then we're trying to separate it into the force so we can set the force of the sum of the forces of the y direction equal to this. So we separate it out. Sorry. This is 7.5 plus 0.25 for the normal force, and then to get F, just divide by the cosine. Okay, so from here we don't know what to do. So we have to find the sum of the forces in the y direction. To find that, we have the normal force minus the force of the sine 30 here, here, and then minus the force of gravity, and set that also to equal to mass times acceleration. Except because it's in the y direction, we know that there is no acceleration in the y direction, so we can set that equal to 0. And now we want to separate the force from the equation. So doing algebra, and we can also plug in the force of gravity, which we know is 9.8 times the mass, and set that equal to the force times sine 30, and then from there divide the sine 30, so we have force normal divided by sine 30 minus 147, if you calculate that out. 147, divide it, which equals the force in the y direction. So because we know the forces are equal, we can set these equations equal to each other. So 7.5 divided by cosine equals 8.66 plus, we'll leave this in form for now, set that equal to force normal divided by sine 30 minus 147 divided by cosine 30, or sine 30, which is just 0.5, so it's 294. And get the variables on the same side. So add it, 302.66, which equals force normal divided by sine 30 minus 0.25 force normal over cosine 30. And then we have to set the denominators equal, combine them. So you get force normal times cosine 30 minus 0.25 force normal sine 30 all over sine 30 cosine 30, and then multiply it out, and you get and you get 131.056, which equals force normal times cosine 30 minus 0.25 times 0.5, which is 0.125 force normal. Combine the terms. Cosine 30 minus 0.25 is 0.741 force normal. Divide it out. Which equals 176.86 equals our force normal. Now that we have the force normal, we're trying to find the force in the x direction. So we plug it back into this equation, and we find down here. So 8.66 So if we calculate that out, and we get 59.7 newtons equals our force. And there you have it.